In order to succeed with hyperspectral imaging, lots of well-ground truth data is required, whether you're building a classification or regression model. The MV.SCAN dual acquisition package is designed to do just that. Acquisition and saving of data cubes can even be controlled with simply the 3 buttons on the per-class MIRA stage. We're going to be demonstrating how to utilize the MV.SCAN dual acquisition package in order to build a regression model to estimate the percent of cayenne pepper in a powdered sample. The MV.SCAN dual acquisition package contains an MVC NIR, which collects data from 900 to 1700 nanometers, the MVC VNIR, which collects data from 400 to 1000 nanometers, a per-class MIRA stage, an optional MVPC. Before data collection, we've created a simple classification model which is able to detect any powdered substance that contains a percentage of cayenne pepper. To start, we initialized the MVC NIR within the per-class MIRA system and then calibrated it collecting a white and dark reference. We then can create a worker instance of per-class MIRA where we're able to initialize a second camera, in this case the MVC VNIR, and we also calibrated that instrument with a white and dark reference similarly. We then created that simple classifier to identify the powdered samples. Now we're ready to collect some data. Using the per-class MIRA stage, we can designate these 3 buttons to do a variety of different commands. I've set it up so that this first green button is going to scan. Per-class MIRA has been set up in scan view, where it will crop around the objects that it detects within the scene and save only the pixels of interest. This drastically compresses the amount of data that we have to save in order to be able to build a hyperspectral model for classification or regression. By pressing the first button, the stage will move from the designated start and end position. Both the VNIR and the NIR camera will be looking for a cayenne powdered sample object. Once it detects that object, it will crop that region from the overall hyperspectral cube that was collected. It will first save it to memory before it saves to disk. This gives me an opportunity to make sure that everything looks good. When I've done so, I've programmed the last button, the red button, to save from memory to disk. And now I can see that I've got a data cube of that powdered sample. I can also increment the sample names so I can move on to my next sample and repeat the process. Now, you can see just how easy it is to use the MV.SCAN dual acquisition package. It's the only system in the market that allows for simultaneous collection from hyperspectral imaging sensors on the per-class MIRA stage. You can use this to collect, train, deploy, and succeed for herbs, spices, or what other applications you might be using this for.